Right. And that's when I say, oh, I have a kid who's in whatever grade, and I know that you learned this then. So I try to bring that back up. But anyway, so parent functions, y equals sine of theta and cosine of theta, theta being the rating address. When we unrolled the unit circle yesterday and Ben walked all the way out to 2 pi, I want you to keep that in mind. When you head on to that rope, you were the rating address. You were whatever angle you were on the card. And from that, we graph sine, and then we graph cosine. The graph comes from you being in that position and moving to whatever the value is on the unit circle. So sine of pi is 0, but cosine of pi is -1. Tangent of pi is also 0. So it depends on what function you're doing, what the graph looks like, but the angle here, I just keep trying to emphasize this so students won't get confused. That's where you are in the unit circle. So let's talk about those things that we just said we were going to name, like domain. You have already told me about domain. Do you remember what you told me? Yes. Because the y is the height. So y equals the height. And the theta, this entire thing, so that's exactly the question. That's what gets people confused. When you look at y equals sine of theta, this is the y value at theta. And that becomes the y value of the function. If you're doing y equals cosine of theta, this goes to the x value on, or at is better, at theta. And that x value becomes the height. That's the output. So what I was trying to do in unrolling the unit circle was have you, the function value is where you move to. So if it says sine, you move to the y of the, we're going to do so many more, hopefully that'll click in. But Elizabeth's question is like right on the money, why I was trying to make the idea of input and output so specific. We'll keep doing it. You keep asking me questions. It's going to click. I just have to find that place where it clicks. Okay, so none of that showed. There it is. When I start the graph again this morning, I'll try to expand on that some more. Domain. Domain, by definition, are the input values. So by definition are the input values. That's nothing new. In this particular group of functions, the input value is the theta, or the place on the unit circle. So it represents theta. They're the angles or position on the unit circle. You're allowed to be anywhere on the unit circle. You're allowed to be at 0. You're allowed to be at pi. You're allowed to be at 45 pi. You're allowed to go around and around and around the circle forever, and you're allowed to go backwards around the circle forever. So domain, besides the definition, domain for trig functions, sine and cosine, is -infinity to infinity. You can plug in anything. If we were looking at our sunrise sunset project, we could have looked at the sunrise and sunset 2 billion years ago. That could be an input value. We would be unwinding the unit circle a lot to get there. So you can input anything. But your output, if you look at a unit circle, so output, which is range, which is the output, if you go around the unit circle, the very largest value you can have is 1, because it's a unit circle. The unit circle is bounded by 1 in every direction. So the highest you can go, or the most right you can go, is 1. That's the biggest value. And the smallest value is -1. So here's what I mean. I'm going to graph sine, y equals sine of theta. Again, I'm going to do 1 revolution around the unit circle, which means I'm going to start at 0. I'm going to start here. I'm going to end at 2 pi. I could do it again and again. Maybe I'll do it again and again so you can see what that looks like. But to do the trig graphs, it's easier to put in the angles on the unit circle on this number line. I could also say that this is 6, if you want to see a regular number. If this is pi, then right here before it is 3, right? My graph's not really to scale, but I also have these values pi over 2, so that's half of pi, half of pi. You can write it 1/2 pi. I could write this as 3/2 pi. That's in between 1 pi and 2 pi. And those 4 places, the like north, south, east, west positions on the unit circle, give me enough that I can get a sketch of it once I know what sine and cosine look like. We graphed it with every single point on the unit circle. We don't want to do that every time because we just don't have that much time in our life. So, sine, the input value is the radian angle. So here's my tiny unit circle. I will go back over to these in a minute. I'm going to use this space for clarity. That's not so bad. I've got 0, 1, 1, 0, negative 1, 0, 0, negative 1. Lovely. Okay, so sine. I'm going to graph sine first. Sine. We go to 0 as an x value, as an input value. That's here. If I'm doing the sine function, then y equals sine of 0. 0 says go to 0 on the unit circle. What is the output? What does this function do to 0? Sine of 0 is 0. It's the y value. So it's not this y value. Sine of 0 means the y value. This is equal to 0. So if I just go like vertically, sine of 0 is 0. The y value is 0. The input is 0. The output is 0. It's a point. That's for the functions graph right here. It's not the point on the unit circle. It's with regard to input and output. It's the trig function applied to the unit circle. If I say the next on my list, so here I'm going to make a list, an XY chart basically, y equals sine of theta. If I input 0, I get out 0. If I input the angle pi over 2, that's the input. It looks like y equals sine of pi over 2. What is sine of pi over 2? Nope, pi over 2. Up here, pi over 2. So I didn't label them all because we need to know them. But here you go, 3 pi over 2. So now I'm talking about just the north, south, east, and west sort of positions. Here's pi over 2. What's the sine value of pi over 2? 1. So we're replacing this with 1. That's the output for this sine function. I plug in pi over 2. I get out 1. So here I go. Pi over 2 is 1. At pi, that says y equals sine of pi. It's the input is the radian address, and these make points. Pi is, sine is 0. It's hard. Like we're having to get over the hump of what's actually happening here. So the sine value is y, so we would go 0. And here's 0 at pi. When we plug in 3 pi of 2 into the sine function, so that means go here, what is sine? It's negative 1. And here you are. And then you plug in 2 pi, because we're going around, and we started at 0, but we end at the same value. The y value, the sine value is 0, and that makes this last point, which gives us the sine curve. And if we went around the unit circle again, we'd have the same values. And if we went backwards around the unit circle, we'd have the same values. So the sine curve goes on and on forever in both directions as you go around and around the circle. So input and output, is that getting better? Okay. So what you get out depends on what function you're doing. If it's the cosine function, you get out all the x values. But they become how the graph is, they become the y values, which is what's confusing. I totally get how that's confusing. So now you can see things that I talked about, like domain is everything, okay? It just does this forever. And then range, the highest value is 1. This is supposed to be 1. And this value is -1. That's the range. It doesn't go any higher than that unless, and we're going to look at these translations here. I'm going to rewrite them so I have more space in a minute. We're going to talk about what happens when you stretch things or shrink things or whatever things. Okay, in my box of stuff, I should have also included period, and I didn't. So I'm going to start a new box and write stuff together for sine and cosine separately. Here we go. Y equals sine of theta. Repetition is good, right? So, domain, again, what's that? All real numbers. Range. And I've got hard brackets here because it does go to -1 and it does go to +1. It has a repeat, a period of what? How far? If we start at this position and we end at this position, we've covered everything. So it's once around the unit circle, it's 2 pi. That means that we get every point in the graph, we get a pattern repeat. If you're hanging up wallpaper and you stop with half of a monkey, you have to start with the other half of a monkey. That's a period. You have to see the pattern from beginning to end in one period. So this period is 2 pi. The amplitude, that's a word I talked about right at the end of class yesterday. The amplitude of the regular sine graph, y equals sine of theta, the amplitude is 1. Because it's from the unit circle and it's 1, this one hasn't been stretched or shrunk. It's the number that's going to be in the front. We'll see one with different amplitudes shortly. I'm going to use a calculator to play with some stuff so you can see it work. And then sine starts at 0, 0. The parent function does. That'll be important for you to tell the difference between sine and cosine. But also sine starts on the midline. And we will look at how that works also. So sine, if you're going to call it sine, it has to start on the midline, and that's just the middle of the graph. All right, so sine is like a parabola. You won't have it go like, here's the middle. It won't go really high here and then short here, right? Because that's not the midline. That doesn't follow that word at all. So midline is that line directly in the middle between the min and the max, like the height, whatever the maximum is and minimum is, that's going to be the average right in the middle. So midline, I don't know that I need to define that anymore, it's the middle. But it's always a y equals line because it's a horizontal line. For y equals sine of x, it's y equals 0 because this is our parent function. And so you can see it right here. This goes up 1 from 0 and down from 0, 1, the same amount. 1 is the amplitude, and the midline is y equals 0. It's the x-axis. So this one is y equals 0 for sine of theta. So it looks like this. It starts at 0, and it ends at 2 pi. There you go. That's a little tiny baby sine, so you can keep it straight. Cosine is the same kind of graph. It has exactly the same domain and range. So it has domain of negative infinity to infinity, range of, oopsies, hard bracket, negative 1 to 1. It has a period of 2 pi. It has an amplitude of 1. It doesn't start at 0, 0 there. Who was 0 for cosine? Where did you start? It's positive 1. And you can look back at your unit circle and go, cosine is positive 1. This is 0. It's positive 1. Cosine starts at 1. So it starts at 0, 1, because 0 is the angle and 1 is the cosine of 0 position, which is sort of what Elizabeth was asking about earlier. So cosine from 0 to 2 pi, if it starts at 1, it has to end at 1, because we need the pattern to come to, like, it has to start and end at the same place. Otherwise, we don't have the entire pattern. At pi, it's at negative 1. So cosine looks like this, and it's half of like a parabola at each end. It's not like a straight line, because what happens after that is it would continue after that. So cosine doesn't start on the midline. Pi over 2 is 0. And 3 pi over 2 is 0. So this does not start on the midline. It starts at a min or a max. And here's the thing, sine and cosine are the same shape graph. It's just they've been shifted. So we could actually name any sine graph, we could name it a cosine graph with a shift to it. And we're going to learn how to do that. So let's look at some things on a calculator so that I can define. I've sort of hinted at what we're going to do up here. I don't know that you're writing this down because I didn't expand on it, but I'm going to expand on it in just a minute. I've got these different things. Can you take a guess at what this A in the front is? Stretch or shrink. So this will change the amplitude, conveniently labeled A. We've been calling it A this whole time. We didn't name it A for amplitude until now, but A. How about C? What will C do? So I'm going to write these out in a second, but while it's here, I'm going to write amplitude. What do you think C does? Left to right. So it's going to have to do with left or right. We're going to consider it with B also, but this is left or right. And then B will actually work on, it'll change the period. So it'll change, instead of the graph going from 0 to 2 pi, it might be a faster curve. So we'll look at that. So let's play with some in a calculator. You can just see what I'm doing. I'll write them down as I go and we'll compare them. C is left or right, but it's not just straightforward as that. I'm gonna write it out more specifically in a minute, okay? So let's see. B is going to change the period, yes. So I don't want to do it on there. I want to do it the big one. Okay, so big graphing, here we go. Okay, so basic sine of x. I'm in radians, so I can see everything from 0 to 2 pi. This is the sine curve. I know this because I'm starting it at 0 on the midline, in the middle, not in a min or a max. But if I graph cosine on the same axes, they obviously look the same, right? It's just they're not one on top of the other. They're not in the same position. So if we moved red this way to the right, how far do you think we have to move it? Pi over 2. So that was part of the cofunction that we had. So if I try to move this dot to this dot, I need to move it by pi over 2. If I move it to the right, how does pi over 2 have to impact my graph here? Is it plus pi over 2 or minus pi over 2? Minus pi over 2. So minus pi divided by 2 graph. So see, y'all are geniuses. Good job. So that makes sense to you, phase shift, from what we did before. We're going to call it phase shift coming up. So sine and cosine are the same graph. They're just shifted because cosine and sine shift on the unit circle. Okay, let's play with amplitude because that's fun. Clear. So I've got sine. Let's see what 2 sine of x looks like. Sine of x. So what do you think is going to happen? Way more wavy. But the zeros will still be zeros because 0 times 2 is still 0. So it's going to be bigger waves as opposed to more wavy. And you'll see what I mean when I make that distinction now. So see, the zeros are still zeros, but the max has been moved up. It's double. It's 2 times. And then the min is 2 times as low. Seems fairly obvious. I could graph more of that. I think you get it. Let's just do something big just for fun. So 10 sine of x, go. Okay. But see, the zeros are still zeros. It only got stretched up. It didn't get stretched out. So this would like be a bigger slinky. I couldn't come up with the word. Yes. 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 Okay, so clear and clear. So if the sine curve looks like this, and I've got a period of 2 pi, and that's, Colin just asked a second ago, what was that b that I had in there? If I write sine, but I say 2x instead of x, guess what will happen? 2 is in parentheses. What happens when things are in parentheses with x? Same math or opposite math? Opposite math. So instead of being 2 times x, it should be opposite. It should be half. And what does that mean? That means there's more bounces because the period is a half as big. So let's see what that looks like. So normally it goes from 0 to this one. But I've got 2 red maxes. I have double the amount in there. Because what happens that 2 times, what it does is it says we're running around the circle faster. So we go around the circle in twice as many times as we would normally. Does that make sense? So it ends up being that our period is half as big because we ran around it faster. That's what the 2 does for our equation. So if you can start to visualize this, then the numbers in the equation won't just be stuff you memorize. You can actually like make sense of it. So let's take that away. We already did phase shift. We've done everything. Let's see, though, I said that last thing didn't change our, let me go back to paper for a sec. Paper. So here was it all written out, new and fresh and with lots of space. So if I'm doing y and I'm doing sine, and if I said bx minus c, that was the original given. Colin asked, and someone asked about c, what that meant. It actually means this sine, and you have to factor out the b to see everything more clearly. And we didn't do this a whole lot. We did a little tiny bit with exponentials. And I said when y'all did some delta math, that's how I thought about working them so that I could find the start point, that little star place that I think about for logarithms and exponentials. But here it's critical because now you can see the actual phase shift, which is left-right shift. We just had to name it fancy and call it phase shift. It's left or right. But we have to factor out the b, and in order to factor out the b, we make this into a fraction. If you multiply this back through, if you distribute the b, you have bx, which is what I have here, and then b times c over b, the b's cancel, and I have the c all by itself. But if you factor out the B, everything is really like straightforward. A is amplitude, and your book goes and says, well, amplitude is really, if you have the midline and you move up 1 or 7 or whatever you move up, you also move down 7, but we're not going to call this -7, we're just going to call it 7. So when the book gives answers, they say the absolute value of that number, and then they consider the plus or minus to be whether it's flipped or not. Okay, so keep that in mind. Also, I should have included the plus or minus before. I've still got the y equals here. There you go. And we're going to look at flip. I can graph those for you too, because that's pretty cool. But so A is for amplitude, and we're just going to consider that the distance from the midline. So it's either up 10, down 10, but it's just 10. If you put -10, I really don't care, but just know that it's 10. And then the number in the front tells if it's flipped or not. As in all things we've graphed, parabolas were positive, they went up, and then if they were negative, they went down. We're going to see that with sine and cosine. B represents the best way to write this is the usual period divided by B equals this function's period. How do I say that good? I'll just say period. In other words, sine and cosine have a usual period of 2 pi. But opposite math says whatever this number is, we divide by it to get this period for this graph. Period of graph. But not all things have a period of 2 pi, so that my little extra stuff here is just because of that. So plus or minus, up or down. A, amplitude. B tells you how many of the graph you have, how many repeats it has. C over B tells you phase shift. So let's look back at the calculator. So if I said, I wanted to move it pi over 2 again, I guess I can do that. Oh, hello. Okay, try again. Sine of, I'm going to change the period to 2, but then I also want to have the phase shift to be pi over 2, like I did with cosine a minute ago. I'd have to say this is going to be pi over 4 in parentheses. So you can see the parentheses. If I multiply this out, 2x, that changes the period. It makes it twice as many in one period, so it makes the period in half. And then this pi over 4 times 2 is really, when you multiply it out, pi over 2. Oh, I think this moves it pi over 4. Oh, I have to play with that better. Pi over, oh, if I want to make it pi over 2, then I need this to say pi over 2 because it's already factored. Okay, there I go. I'm trying to show the same phase shift I had before. I'm doing a bad job of it. This, let's do just one thing at a time so you can actually see it. Delete. This, I have extra parentheses, but this is just the phase shift all by itself. So when I graph it, we can see it. I moved it over pi over 2. If I want to have it move over and do phase shift, then I need to go here and factor out the 2, insert, oops, sorry people at home, second, insert 2, there we go. So second, delete, so insert is right above it. That would be great. Yeah, that's handy because I goof up all the time. Okay, that's a lot to look at. Let's look at clear. Let's look at the plus or minus. All right. The stuff that you have to do for Khan Academy for tomorrow, This covers more of it. Like, you're going to be able to pick out amplitudes and stuff from the Khan Academy with what we've just talked about. Next week, we're actually going to plug in stuff and do work, and add the other graphs to it. But we've just got 4 minutes left, so I want to play with it on the calculator so you can see what positive and negative does. If sine of x starts at 0, what do you think sine of negative x starts at? Let's look at it and see if it makes sense. Okay, so it starts at 0 too. Sine starts at 0. Sine starts at 0. It was a tricky question because I asked you, you thought you needed a different answer. But 0 switched over is still 0 because it's the midline, but the max turned into a min, blue max turned into red min, and the min turned into a max, so it's flipped over. But it's still the sine wave because it starts at 0 at the midline. Does that make sense? So I can say it starts at 0, it has a part that's down and a part that's up, and it ends at 0. That's one period of sine. It's not quite time to go yet, so just chill. If I graph cosine, and it starts, at 1, cosine of x, starts at 1, there it is, 1. And in fact, if you just want to see it like just one iteration of it, one period, that might be helpful. So here's pi, somewhere, pi, graph. Oh, that's really ugly. I don't like that at all. Let's try again. Let's do to 2 pi. That would be better because that makes way more sense. 2 pi. There we go. There's cosine. Starts at the top, ends at the top. This is one period of it. And if we flip it over, so negative cosine of x, it doesn't start at 1 anymore. It starts at the bottom. But 0 is still 0 and 0 is still 0. But the mins and maxes have changed. Okay? So for me, I feel like this is a whole lot like all the other translations we've done. Okay, so this is vertical flip. This is stretch, but the stretch looks different with this kind of function. This is new, the period. We haven't had that before. But this phase shift, although a little bit different with the fraction, is still phase shift. Okay, so you have Khan Academy that's due tomorrow, and that's it for the weekend. And then Monday, we're going to look at the other functions, and we'll start again